Solid.js. I'm going to explain some things that I've learned so far, and then I'm going to go over these tutorials here, and maybe I'll stop on the tutorials in the middle, and then I'll continue to try to refactor this project that I'm working on, which is solid. So I don't know if what I'm going to explain is 100% correct, but that's how I'm thinking so far. So the way that... put some music. So the biggest difference, I think, from React to Solid is that on React you have this... obviously, they both are going to have the DOM tree. And then on React, the way that it works is that you have this guy here, which is the fiber work loop. And it's going to traverse the nodes. And then it's going to compare to see if the state changed or not. And if the state changed, then it's going to update the state, which means it's going to run the function for the component again. So it re-renders the entire component. And on Solid, the only difference is that instead of going over the elements, the DOM elements, the components again, it's just gonna go over the variables that you assign inside of the components. So it's more flexible and more granular. So it still compares the previous state with the new one, but it does that on the level of the variables, which are signals or stores. And then there's some variations of that. So that's the biggest difference. Solid updates on the variable level and React updates at the component level. And it is like a small difference, but it does a very big difference. I think like the impact that it has is very big. So the way that Solid achieves this is by using proxies. And I'm going to try to explain 2 different ways here what a proxy is, but it's pretty much there's a site called Upwork and a site called Fiverr, and it is for freelancing things. So you have the seller which wants to sell a service, and then you have the buyer which wants to buy a service. But the problem is that the person that is gonna buy doesn't want to directly pay the seller because they don't trust them. So that's the purpose of the Fiverr or Upwork. It allows the buyer to put the money on the site, and then the Upwork is like the middleman between the seller and the buyer. And that's pretty much what a proxy is. It's just the middleman of 2 different things. So in JavaScript, you can have an object, for example, and then every time you access that object, you would have the proxy, which works as the middleman, and then it allows you to put some functionality that is going to happen as you access the object or as you set the object. Those are the most common, I think, use cases. So it's either getters or setters. So if you're accessing, for example, let's say you have a proxy is an object and you want to access the value like this, then if you don't have a proxy, the only thing that is going to happen is you're going to get the value that is equivalent to this on the object. But if you do have a proxy, then it allows you to put some functions that are going to happen as you access the value. And that's the middleman. And the other way to describe is like with a drug dealer. Let's say you have a guy that wants to buy guns, and he doesn't want to buy the guns directly because the guy might just steal from him, and then, but he knows this middleman which he trusts a lot. So what he does, and the middleman knows the drug dealer as well. So what he does is just send the money to the middleman instead, and the middleman does the transaction. And then one thing that this guy might want as well is like he might say to the middleman, hey, before you buy the guns, just go around the block and see if there are cops, for example. So like he's specifying some additional stuff that the middleman's gonna do before he does whatever it is that the client wants. And that's the purpose of the proxy. So the proxy would be a middleman. And in Solid is like you have a bunch of proxies connected together. So every signal or every store you put on Solid, which is this variables here inside of the nodes, is like one of these middlemans here, and they're all connected together. So it's like you're passing information. So if you have a signal that depends on another signal, every time that one of the signals is triggered, then it's going to trigger the other ones. It's going to create this cascade effect. which is very similar to the way that React works, but it's just different levels of granularity. And that's the biggest difference, I think, from both of them. So the consequence of this is that on Solid, it allows you to have more flexibility, because you can, it's kind of hard to put into words, but you can set the state in a more flexible way, because it depends on the variable and not the component itself. On React, every time that something changes, it has to re-render the components, the entire component. But on Solid, it only re-renders the specific thing that is set by the signal or the store value. And this has, I don't explain context very much because I still don't understand very well, but it has a big impact on context, because in Solid, it allows you to just have, instead of having to create a context for the global variables, you can just create global signals and global stores. And that allows you to just have something that would be equivalent to a context. But then in Solid, the purpose of the context is to create dependency injection. So the situation where this happens is, for example, you have a component that is going to hold some state. In my case would be the canvas. So I have a canvas component that hold, and inside of these canvas components, I have several other different components that I don't wanna pass information from the top to the bottom. I wanna be able to pass information from this node here to the one up here, and that's the purpose of context. But at the same time, if I have multiple instances of the canvas on the website, I don't want the state of the two different canvases to interact with each other. So if I change the state of one of the canvas here, I don't want to impact the other one. And that's the purpose of the dependency injection. So you use context to allow you to limit the scope of something towards only a part of the tree. And the way that it feels to me so far is that Solid is pretty much React with all the problems fixed. At least that's how I feel like it right now. But I don't have a lot of experience, so yeah. So now the biggest challenge that I have now is just I'm trying to think about how to convert the Zustand stars that I have on Solid, that I have on React, on the app that I was building, to Solid.js. And the issue that I'm getting into is an issue that I got as I was creating the store. I was thinking about this as well, because you have two ends of the spectrum, and I think that's the evolution of front end in general. I think it's just about finding which is going to be related to a fundamental structure of spacetime. It's going to be finding the middle way between the two extremes, which is going to depend on the context. So just like the difference on React and Solid is the level at which they update things, which is going to make all the difference, because that's how front-end works, is that you're always going to need to update state at some level. And the way that you choose to update is going to change the whole performance of the application, because it changes the way that you're going to navigate the tree with the fiber and do the updates. So it's the same thing with the stars. So in React, the purpose of having Zustand and other things is, it seems like to me intuitively that what's happening is that React is trying to achieve what Solid achieves naturally with the stores. So because of the way that the update mechanism works on React, you need an additional library to handle the context and the state management of the context, because it allows you to go more towards the way that Solid works naturally. So in Solid, it doesn't make a lot of sense to have additional libraries. I think you can just use the normal context. But I found out about this library as well that works. It is pretty much the purpose is to be the Zustand version of the Solid version of the Zustand. So it just works like Zustand but for Solid. And the way that so the biggest challenge here in the way that the Solid works is that because it works with a proxy, you have, whenever you're setting a value, you have to, at least from what I know now, you have to specify the path for the value. So for example, if you have a nested object, I'll go on the example. So if you have this, maybe the stars example is better. So if you have a nested object, you can specify the path for the object. So if you have key value pairs nested, for example, and have key 1, value 1, and then value 1 is another object, you can, whenever you're setting the state, you can pass the first argument as the key 1, the second argument is going to be key 2, and so on. Like you pass the path for the accessing the variable, and then you pass the new value that the variable is gonna have. But that's kind of confusing to me. So the biggest challenge is on this updating mechanism is how understanding what is the best way to update things. So for example, here you can pass, like they say here. So you pass the variable on the state. And this brings me to the question that I have now that I'm trying to figure out, which is that on React, when you create a Zustand store, the whole thing is going to be an object, which is the state. And the way that you set the patterns is by accessing the state and then doing shallow. If you want to do deep copy, so shallow copy is when you just copy the first level of the object. You don't copy the object itself, you just copy the reference. And then deep copy is when you copy everything. So Solid.js and I think Zustand do shallow copies. So if you have nested objects, it's not going to copy the values of the whole object. So you have to manually copy them, as far as I understand now. And you do that by using the spread operator. So this didn't change yet, but it is a Zustand store. So every time you're gonna set one of these values, so for example, when I access this on somewhere else, this is already the function that spreads the whole state. So it's copying the whole state with the spread operator and just adding the additional value. And then you access this variable by calling the use config store hook here that I created, that I just got from somewhere else that I don't remember. But yeah, you just access the context. This one I changed. It was using the use store hook, and then passing selectors and some other arguments here. That's one of the biggest changes from the way that the other library works, because on the version, it's kind of complex, so it's kind of hard to explain. But on the version that I had before, I was using useRef, which is a hook on React that allows you to have the same thing for several different rendering cycles. And the reason why I was using that is because I wanted to achieve the dependency injection pattern on React. And the way that they recommend you to do this is on the Zustand documentation, they use this pattern here. So you pretty much create the store based on the useRef, which allows you to have the same store. So the effect that it has is that it creates dependency injection. But the thing is that on Solid.js, it's already dependency injection by default if you just use the context, as far as I understand now. So obviously you don't need to use the useRef here, and then you don't need to do things the way that I did here. So I was using the use store hook here and accessing the store like that. So now I'm trying to figure out what is the best way to refactor this. So either I use the context or I just change this code so that it works with the other library. It's kind of confusing because this library doesn't use the dependency injection pattern. So this is the problem, is that if I just do things the way that this library does, then it creates the store for the global value. It doesn't limit the scope. So if you just create the store like this, it's going to create a situation where you don't have this thing here. The store is going to be for the whole app, and that's the problem. Because then it doesn't allow you to separate the state of two dependencies, two different instances of the components that you're using the store for. So for that reason, I think that, I don't know, it seems like it is not a very good idea in Solid.js to use this library. I think it's probably better to just create the values themselves. So either create a solid store or a solid signal, which are the things that you use on Solid to create these reactive patterns, which is pretty much the way you say to the framework what you want to update based on the state. And as far as I understand now, the create store is more for when you have more complex data structures like objects and arrays, or arrays of objects and stuff like that. And the signals is more for when you have simple data structures like strings and integers or floats. So yeah, but they both accomplish the same thing. They use proxies under the hood to do the diffing, which is the comparison between the previous state and the new state in order to update the DOM. So the question that I have here now is that the way that it works on React when you use Zustand is that you just have one object. And it is a question that I had before, which is like, there's always this balance. Like, either I can do the pattern that I do here. Like, this is one of the problems that I have right now, because on one of Ryan's talks, which I highly recommend listening to, there's a lot of useful information. But in this talk here, around the 1 hour and 8 minute mark, he says something about you shouldn't do this pattern here, where you're calling a function and spreading the function to an object on Solid, and I think it's probably something related to the way that the proxy works. So obviously I can, instead of doing things like this here, because when I call this function, this is the store that I have here. So it's just accessing these values here. It's like I'm replacing all these values inside of here when I call the function and I spread into an object, and I want to do that because I want to pass these values of the context, so I have access to these values on the other components of the tree. But obviously this is not recommended based on what he said. I don't understand very well why. So one of the things I could do is, obviously, instead of doing that, I could just spread here and then just manually copy all the values here, and then call the function, make it equal, call store, and then pass the actual values here. But I'm also not really sure if that's a good thing to do. And in the documentation, the thing is that they recommend you to, when you're using context, to do it like this, where you're just creating one store, and then here it creates another data structure to set up different functions for changing the value of the store. So here it would be like the same thing that I'm doing there, but slightly different, I think. So instead of initializing inside of the Zustand store, I would create the one store here, and then I would do the same thing that I did for these variables here, where I would put the functions. Where is this? I would put the functions inside of this array here. So I would create one massive array, and then I would have the state, which would be the state of the whole store, which would be this whole object here. And then instead of putting the functions here inside, I would just put them on the array as well. And then I would pass this value here as the state. And then when I want to access, I assume that I will have to destructure the value so I can get access to all the functions, or I can create an object instead of an array here, and then I would destructure to access. So it's pretty similar. But the question that I have with that is that, because of the way that I think the universe works, is that you're always going to have a polarity and you're always going to have two ends of the spectrum. And the arrow of time is the evolution between different relative polarities. So the passage of time itself is, the natural tendency of the universe is for increasing entropy, which is the disorder. And as a reaction for that, the essence of life is increasing information, because they are balancing effects. So the nature of time itself is the evolution of information, which happens as a consequence of the chaos of the universe, and the essence of life, which is the movement of time. And that means that you're always going to have different polarities, and the evolution of any state of any system is going to be to increase the complexity in relationship to a reference frame over what the system is. So to simplify, what I'm trying to say is that here you're going to have two ends of, in my mind, you're going to have two ends of the spectrum. One is when you have just one big object. Like, let's say, imagine I have like extremely complex data structure here that has a lot more values. One extreme would be to do the same thing that I'm doing here, which is using the Zustand store, which you have one massive object, and then you copy the object, and then when you want to do more complex operations, you have to spread like this, because it does a shallow copy, so we have to manually copy everything here, which is more like this approach that they are advising to do here. You just create one store, and then you update the whole store every time that something changes, and then you have to manually set. But I don't like that approach very much because of the stuff that I just said about the space and time and information. So the other approach would be to create a single value for each thing. So you can imagine that for each object that I have here, each one of these values that will be an object, I created a separate store. And then for each value that is a string, I create a signal, or a string or a float or something simple. I create a signal. And that is also, it seems better because then it allows you to have more flexibility and it's easier to update each thing. Because then if I want to update a value of string, I don't need to copy the whole state. You can just update that value. So, and then along the middle between these two approaches, I think is going to be the optimal approach, which is going to depend on the circumstance of the environment. So each application is going to have one variation of this, and that's going to be the convergence of information. So the challenge is always going to be to find the complexity that is optimal for the thing that you're trying to do, which is going to be the middle way between the two. And I think in my case, it's probably going to be to separate the... So this is the reason why I'm thinking about not using the Zustand store anymore, because I think it's going to be slightly unoptimal. And also because of the way... And this is something that I have to study now, which is the... And that's the whole complexity of the framework, I think. And the natural evolution of all the front-end frameworks are going to be based on this, which is the... And this is something that I realized just now, like a couple of days ago, which is that the complexity of data is directly related with the updating mechanism. So there's always this gradient. Because I was thinking about all this stuff about the store, I think that's it's going to be a multifractal pattern that determines how different frameworks evolve over time. And the difference between them is going to be the situation depending on what you want to do. So different applications are going to, like the frameworks are going to specialize in certain areas of space-time that incentivize different reactivity approaches, which is already what's happening, and it's going to continue to happen like that, I think. And it's just going to increase more and more the granularity and the nuance on which you update. So for example, you could have a framework that works in a similar way that React works, but then for some components, it allows you to have the reactivity approach from Solid.js. And I think that's kind of what's happening with the server components. And I think that's going to be the evolution of things. So the challenge in any framework or in any state is going to be finding the optimal way you update each value, which is always going to depend on the context of what you're trying to do. And then here on this library, the way that they do it, and Solid does have these things that I don't understand very well, which is a function called reconcile, and then they have create mutable, which is another way to create store. But then the main changes of this is the way that they are gonna do the diffing, which is the comparison between the previous state and the next state, and the way that they are gonna set up the proxies. So I think that this is the key to becoming better at Solid and understanding what's the best way to do things. And that's what I want to do now. I want to go over the tutorials more to understand what's going on. But probably what I'm going to do is I'm not going to use the library. I'm just going to pass all these values here. I'm going to create separate components so I don't put all the code here. But I'm going to create a component here that is like can be the name of this config provider. And then this component is gonna have the text, there's gonna be an object that has all the values here. Something I don't understand very well as well is that I've seen some stuff about you're not able to destructure props on Solid, but as far as I've tested now, it seems like it is working. So before I did all this stuff, I was gradually translating everything, and it seems like it was working, so I think that it is possible. But that's probably what I'm going to do here. So I'm just going to translate these values into separate values that are either signals or stores, depending on what the complexity of the data structure. And then the challenge is how do you decide which one is which, and then how do you use this other hooks and these other functions to determine what is the best way to update the values. Because the annoying part is that, like, I'm going to access these values here from the other components, obviously. So these functions are the setters, and then the first value is the getter. So the first value allows you to get the value that you are creating, and the second one allows you to set the value. And the main difference between the use state in React is that in React, the first value is a variable, the second value is a function, but on Solid, the first value is a function. And the reason why is because it's not that it is, Ryan says to not think about it as a variable, is like, as a function. It is more to think about it as a variable. The function is just an interface that allows you to create the reactivity by calling the function in multiple different places. So that's the reason why it's a function, is because it has to be reactive, and because the component only runs once. So the reactivity comes from the thing itself. So the function is just a function because it's an interface to a variable, but you can the best way to think about it is as if it is the variable itself, because it works like a proxy. So when you call the function, it's gonna do some other functionality under the hood, which is the proxy mechanism, which is probably, I'm not 100% sure, but I think is the diffing mechanism. So instead of the way that React works, where it diffs based on the component, the entire component, the thing diffs on the variable itself, which is a proxy. So the diffing mechanism is inside of the proxy. So here, probably what I'm gonna do is just create a bunch of different signals. And then the annoying thing is that on the other components, I'm gonna access these values and then I'm gonna call them. And then obviously, depending on the way that it's structured here, I'm gonna have to set the state on a different way because of the shallow merge, and because there's some nuance about context and reactivity. And this is the tricky part that I'm trying to understand, because everything works as a proxy, then there might be some mechanisms under the hood that when you put these proxies on the context, it makes them lose reactivity, which means that they don't update in the way that it is intended for them to update. And the biggest change is in the way that we're gonna call these functions here across the app that are gonna update the state on different times based on what I wanna do. And here I have 3 Zustand stars that I was using to manage the state of the graph. So in all of them, I'm setting up a bunch of these functions here that are gonna change the nodes and edges and change the physics and stuff like that. So depending on the way that I decide to separate the data structure here, or like how many stars I'm going to use, how many signals, I'm going to have to change everything else to reflect the change here and to see if it still has the effect that I wanted to have. And how I'm going to do it. So like, for example, right now I'm probably setting the nodes somewhere. Let me see if I can find the... I'm setting the edges. Edges is better because then... And the way that I'm doing that is just by changing the value here. Maybe edges is not the best because it's not setting using the store. And this is kind of complicated too. Pretty much I'm changing these values here based on the state of the store. So when I change, the question is when I change to signals and stores, if it is gonna have the same effect as it has now, as I was using the Zustand thing. Oh, the other big difference between Solid and React is that in Solid you don't have the use graph hook because everything only runs once. So the way that you access components is just by creating a variable on the global, not the global scope, but the local scope of the function. And then just passing the ref here. And then as the components are rendered, it assigns the value, I think. And then you can use there's 2 different types of effect. One's the create effect, the other is create render effect. And it's very similar to the way that use layout effect works and use effect. But the difference is that they only run once. So the create effect allows you to put an effect based on a signal, which is something that is going to run every time that the signal changes. So you don't need to put the dependency array. And create render effect, I'm not 100% sure, but I think it's for when you want to change the state before the DOM, before the element gets put on the DOM. The first execution of effect function. Component rendering phase should be complete. Yeah, so create effect waits for the rendering phase and create render effect runs immediately. That's the biggest difference. So the way that I think about it is just create render effects is the use layout effect version, and create effect is just the use effect. But obviously they're different because of the way that Solid updates the state. So the biggest challenge now is to understand. Oh, there's also this control flows things here, components that he pretty much puts the patterns that happen most often, which is you want to render something when a variable is true and then something else when it's not, or something like that. And then you can have several different conditions, which is just the ternaries operators that people usually put on inside of the JSX to specify what's going to render based on the state. That's the switch, a match, and the show. Then he created a for loop thing component, which achieves pretty much the same thing that you achieve when you map. But then there's some difference because the reason why he created this is because of the way that reactivity works, and I still don't understand very well, like what are the differences. And there's also some special stuff about the transitions and suspense that I don't understand very well yet. But the main thing that I want to understand now is the difference between this store utilities here, I think. So it's the difference between this produce, reconcile, the create mutable, and the create store. And then I have to think about how I'm going to structure this thing here. So let me do one, for example. So this, for example, would be create signal. And then I pass through here, because this is a simple value. And then in here you have to pass as the now I'm not 100% sure, like maybe it's better to pass like this because you want to call. Yeah, maybe you pass like this because when you call, this is a function, and when you call the function you get the actual value. But I think it's better to pass like this, because then on another component we're gonna use these values, you would call the context, store, use context, config, context. So this would be these values here that you pass, and then you would access stories, reg active, and then you would call. And then here it would be where you would put the thing that this states where you want to access the thing. So every time you want to access this variable, you have to call. But it's very similar to the way that React works with the use state. And this is what I'm thinking about now, is that I should... what should I do here? Then obviously I would pass this as well. And I think this is probably the best way, so not use a solid Zustand and just create a bunch of variables here. Some are signals, some are stars, and then I pass all the values here inside. And then I have to change everything else, because here I'm using I was using the Zustand, obviously, so the way that I'm accessing value is by accessing the state. It's a function that receives the state as an argument, and then it returns whatever value you want to access. So this would be the function inside of the store there. So I'm accessing like this, but now, because I have to change everything, I'm gonna have to change the way that I'm accessing everything. And the reason why I don't wanna do it right away is because of this fundamental thing, because I understand that the best way is gonna depend on the context, which depends on the information, depends the state of the things, and then the nuances are gonna be on the way that the way that Solid updates the proxies, I think, and that's the diffing. So that's what I'm trying to clarify. And after I clarify that, then I might go deeper into the transitions as well and the fallback. So other differences in the way that it renders the pages. There's also this batch here thing that I think that it is supposed to create multiple different changes at the same time. Hey Mohammed, what's up? So it's kind of like a promise.all thing, where it allows you to put a bunch of things to update at the same time. Because every time a signal runs, it updates the thing. So if you use batch, it updates. Let's say I have multiple different signals, and then they're all gonna update one by one, but if you put inside of the batch, it updates everything at the same time, I think. And the other kind of hard thing to understand is the thing about derivatives, where you have, like, when you have signals that depend on other signals, it's gonna create this cascading effect. It's kind of like it's similar to events, the way the events work. Whenever there's an event on the dome, it's gonna bubble down until it gets to the target, and then it's gonna bubble up again, and it's gonna pass the event to other elements unless you call the stop propagation thing. So it's kind of like that with the states as well. Solid. Whenever you have signals or stars, and you have other things that depend on that, it's gonna cascade to everywhere. And then there's some nuances, obviously, on the way that the optimal way to separate things. So I think I'm just gonna follow this tutorial here again. I think you can... On previous time that I did this, I just went one by one here. And I didn't do anything with the code, I just read. I kind of prefer to listen to the music now. Then putting this up, maybe I'll change. So here is the beginning, it's pretty simple. It works in the same way that React works, I think. But the only difference is that in React, obviously, it's going to be React DOM that does the render. And the render accepts the children is going to be the thing that initializes the Fiber work loop. So, like the elements you pass here are always going to work as a tree because it's the DOM tree. There's this tree here, and then the rendering thing is going to be the little thing here that I did, the guy, which is the Fiber work loop that traverses the tree and checks to see what's happening with the state, and there's the diffing. But obviously in Solid it's going to be on the variables. Yeah, I'm just gonna skip these ones because maybe you should try to see if I can change there, how it works to change. I don't know if they give you an assignment for each one. I guess let me try to do this. Let's put nested here. And there we go. Signals are the cornerstone of reactivity in Solid. They contain values that change over time. When you change a signal value, it automatically updates anything that it uses. After studying more Solid, I think that there's no reason to use React, probably. It feels to me that it's much better. It's like everything that was bad about React was fixed, and it is embedded into the framework. But I'm not really sure about this because obviously I don't have experience, so there might be situations where React is better. Because the main concern that I have is that I might not be able to do the website that I'm trying to do because the components only render once, and the way that I set everything up, it was by thinking that they would run more than one time. So I did everything based on the facts, based on the dependencies, and changing this, it might be just too hard to make it work, but hopefully not. But I think that the natural progression is probably true, is solid. And I think the other frameworks, I don't know them very well, but they are pretty much the same. But Ryan says in one of his videos as well, and I think I agree with his philosophy, which is that he says that Svelte tries to make everything seem easy, and then you add complexity as you go. And then Ryan's philosophy is more like, here's the way that it is, and then once you figure it out, then you're good to go. So it's harder on the beginning, but over the long term is better. And I think I prefer this philosophy much more than the other one. But obviously I don't think it's better or worse, it's just different points of view. But I didn't like Svelte very much. And then Vue, I don't have experience, but I've heard that it is good. So, but I think all of them are gonna be based on this distribution of the main relationship is data complexity with the updating mechanism. I think that's always the relationship that is gonna happen. And the gradient of where they're gonna be updated. So the more complex the data, the more complex the updating mechanism has to be in order to maintain or increase efficiency. And I think that's the relationship. So as time goes by, things seem to become more complex, because that's the essence of time itself, is the evolution of information. So the natural tendency is for frameworks to become more complex in the way that they choose to update everything. Pass the create call is the initial value and the return value is an array of two functions, a getter and setter. But destructuring, we can name these functions whatever we like. In this case, we can name, sorry, let me just copy the thing there. It's important to notice that the first returned value is a getter, function returning the current value, not the value itself. This is because the framework needs to keep track of where the signal is read, so it can update things accordingly. In this lesson, we will use JavaScript's set interval function to create a periodically incrementing counter. You can update our counter signal every second by adding this code to our counter component. Each tick, we read the previous count, add 1, and set the new value. So this is another thing that I'm not sure. The only downside with Solid so far that I'm experiencing is that the documentation is a lot worse. Like there's less, and obviously that makes sense because there's less people using it. So, but yeah, I think like it makes it more challenging to learn. I think in the beginning. So one of the things that I'm not really sure is how, because in React, they recommend you to a lot of the times put a function here instead of passing the actual thing. And I think the reason why they recommend this is because every time that the component re-renders, you have to create a new object or a new reference to the, maybe a new object. React creates a new object every time that it re-renders. So I'm not 100% sure why, but I think it is related to this. Like people suggest you to put the function so that in some cases it doesn't mess up, because if you don't do it with function, it doesn't create something new. You just change the one that you had before, and then there might be some tricky situations where it fucks up the state. So sometimes like a lot of the times people incentivize you to pass the function, not the value itself. But it seems to me that on Solid it's not like that. It doesn't matter. So you can pass either the value or the function, but it doesn't have that big of a difference. But then the only place where it does have a difference is when you're using the store and when you have a complex data structure and you want to update, because then you have, and this is the stuff that I'm not 100% sure, but I think you have to spread everything and manually copy everything. after you set. So I'm not sure. I think it's not working here. I'm not sure why. Oh, it's because I have to put count here, I think. Does this work? No, it has to be a variable. And now it should work, I think. Hey, TikTok boom. What's up? Yeah, now it's working. Why? Signals are... There's something about trackable values as well. I have to watch all of these lectures. Not lectures, streams, but they talk about trackable something here, but I don't... Like, they didn't go into depth, so... I don't understand really well what that means, but I think I assume that it is related to... Like, when you create a signal, you create a proxy, so it is tracking... So I think under the hood, what is happening is that as you create the signal or the store, like the functions that are part of the proxy. So the main thing of the framework is whatever they decide to put in the proxy itself. And I think that's how the entire framework is based on. So the functions but I don't know like how those functions work, but they are the ones that determine how the framework is gonna work. So every time you're accessing the value or getting or setting, those functions are going to be called under the hood. And I think that's what they mean by tracking. That there's something on those functions that keeps a reference to their object. So, and there's something about subscription here as well. So I think every time you create a signal, you're subscribing to an effect. So that's probably how it works. Like they keep track of maybe an object or something like that has all the places where the thing is used on the app. And then every time that the value is called or changes, it goes to the subscription and does something, I think. Yeah, nice. I'm from Brazil. An effect can be created by importing create effect from solid.js function. The effect automatically subscribes to any signal that is read during the function's execution and reruns when any of them change. So this is something that I'm not really sure as well. I think that if you want the effect to rerun, so like signals are the equivalent of dependencies, I think, on Solid. So on React, what you would do is just put the value of the count on the dependency array here. But then on Solid, what you have to do is just use the value inside of the effect, and then it's going to run every time the value changes. But if the effect doesn't have any signals, I think, or signals or stores, then I think that the effect only runs once. But I'm not 100% sure about this. It depends. Dependent signal change. This is how rendering works in Solid. Rendering is just a side effect of the reactive system. Effects that developers create with create effect run after rendering has completed, and are mostly used for scheduling updates that interact with the DOM. If you want to modify the DOM earlier, use create render effect. We've seen that whenever we access a signal in JSX, it will automatically update the view when the signal changes, but the component function itself only executes once. You can create new expressions that depend on signals by wrapping a signal in a function. You can create new expressions that depend on signals by wrapping a signal in a function. A function that accesses a signal is effectively also a signal. When it's wrapped signal changes, it will in turn update its readers. So it's like updating by proxy, because one of the signals is going to change, then it's going to change the other function. It's not that hard to understand, I think. Call functions like this derive signals because they gain their reactivity from the signal they access. They don't themselves store a value. If you create a derived signal but never call it, it will be stripped from Solid's output like any unused function, but they will update any effects that depend on them. They will trigger a reminder if included in the view. Most of the time, composing derived signals is efficient. However, it is sometimes beneficial to cache values in order to reduce duplicated work. We can use memos to evaluate a function and store the result until its dependency changes. So this is one of the big difference between, not big difference, but a small difference between Solid and React, is that in Solid you obviously don't need use callbacks because everything only runs once. So the only thing they have is create memo, which is similar to use memo on React, I think. Just memoizes the value you put, but there's some changes. Yeah, I'm gonna read this because I'm not 100% sure how it works. Because I was seeing on React you have the dependency, on Solid you don't. So this is great for caching calculations for effects that have other dependencies and mitigating the work required for expensive operations like DOM node creation. Memos are both an observer like an effect and a read-only signal, since they are aware of both their dependencies and their observers. They can ensure that they run only once for any change. This makes them preferable to registering effects that write signals. Not sure if I understand this. So use it when you want to only run that once and not every time that one of the dependencies of the function changes, I think. Memos are both an observer like an effect and a read-only signal. Since they are aware of both their dependencies and their observers, they can ensure that they run only once for any change. Oh, because they don't want to recalculate the value. I think that's why. So here, because you have two different... Oh, actually you have the same function. So this would be... Yeah, but it would be two different signals inside of this function. So it would just create an infinite loop, I think. Because one signal triggers the other, so it runs multiple different times. But then if you use the create memo, it only runs the thing once for the function, I think. It's kind of confusing to understand. Oh, I'll be right back. So I think if you don't memorize, you would run all the signals despite the value changing or not. Because here the function depends on both the signals. So if you don't memorize, it runs all the signals, so it calculates everything again. But if you memorize, it just runs whatever signals changed, and not all of them. So I think that's I think the biggest reason to use the create memo on Solid is whenever you have multiple signals inside of a function, or whenever you have at least one signal more on the function. So if a function depends at least on 2 signals, then you should memorize, I think. Sure that they run only once for any change. Let's make them prefer to registering effects that write to signals. Can be derived. Should be derived. I think that makes sense. Creating a memo is as simple as passing a function to create memo imported from SolidJS. The calculated value gets increasingly more expensive with each click. If we wrap increment, it recalculates only once per click.
The mystery of life isn't a problem to solve, but a reality to experience.
Yeah, so it's here. Also, it shows the solution. Yeah. JSX allows you to use JavaScript to control the logic flow in the templates. However, without the virtual DOM, using things like array prototype map would wastefully recreate all the DOM nodes on every update. Instead, it is common for reactive libraries to use template helpers. In Solid, we wrap them in components. I forgot just to mention this. I was explaining this thing. So React always I'm gonna say, but whatever. I should have said on the beginning, but I forgot about it. But React has 2 different trees, actually. One is the virtual DOM and the other one is the real DOM. So whenever the guys, which is the fiber here, it actually goes on the virtual one, and then it sees, and then if it does have a change, then it replaces. It does the change and then it replaces the 2 trees. So it changes everything, and then once everything is ready, it replaces the virtual one with the real one. So it always has the 2 different ones, but then it updates the state on the virtual and then it swaps them, I think, when the changes are made. I'm not 100% sure, but decently confident that that's what happens. The most basic control flow is the conditional. Solid's compiler is smart enough to optimally handle ternaries and Boolean expressions. However, often it is more readable to use Solid's show component. So I think the biggest difference here is that because Solid doesn't have the virtual DOM, it has to recreate everything. And on React, because it has the virtual DOM, it just swaps the virtual with the real when it updates. So it's never recreating the components, it's just swapping them after the update. But because Solid doesn't have the virtual, it has to recreate if you use the map. So they created these special components to optimize for this stuff. But it still allows you to use the other ones, but it's just more optimal. Choose these ones because they do something under the hood, which he explains here as well. a little bit. It's just a fragment. It uses it calls the map inside of the fragment, I think, and then just calls for the children or something like that. Don't remember really well. The example we would like to show only the appropriate button that reflects the current state when the user is logged in. The gesture. So just put show here. And there's a when. And this is going to be the value. So it's kind of like doing the AND operator, where it puts a variable, which is a very common pattern. And the fallback is when it's false. The for component is the best way to loop over an array of objects. As the array changes, for updates or moves the items in the DOM rather than recreating them. Let's look at an example. I don't think I'm gonna do this once. I'm gonna go faster until I get to the... I'm just gonna read them, and then once I get to the stores and the other stuff, then I stopped more. And this is what I felt that is missing. I couldn't find videos or more, not a lot, but more information about these nuances on the updates. So hopefully I can study and then learn everything, and then I can make the videos and maybe write the information as well on my blog. So, but the issue, like the biggest challenge that I have, I think these styles of streaming is probably better because obviously I don't know the thing very well, so I didn't create a framework. So like I'm always concerned that if I make a video like specifically teaching this stuff, maybe I'm teaching the wrong way because I don't know very well how it works under the hood. But I think that streams like this where I'm just learning, because then it's better because people will come assuming that I don't know this stuff, so they will do their own research. I think it's better this way. There's one prop on the for component each where you pass the array to loop over. Then instead of writing those directly between for and for, you pass a callback. This is a function similar to JavaScript's map callback. For each element in the array, the callback is called with the elements the first argument and the index as the second. You can then make use of those in the callback. Should return a node should be rendered. Note that the index is a signal, not a constant number. This is because so the index is a function, not a variable. Keyed by reference, which is because for is keyed by reference. Each node that it renders is coupled to an element in the array. In other words, if an element changes placement in the array rather than being destroyed and created, the corresponding node will move to and its index will change. Each prop expects an array, but you can turn other iterable objects into arrays with utilities like array from object keys. The other thing that I'm trying to think about is that on the documentation they say that when you're using classes, you can create a store for a class, but then the class is not going to be reactive by default. So this is also kind of confusing to me, because here on the store that I have, I'm creating I have this graph class from Graphology, and then I'm not really sure how to convert this one into stores. Because if you use a store, it's not gonna update this store, or like you have to create a function that updates the thing in a different way. And here it's kind of tricky because I don't remember, like the only place that I'm using this still is on the layouts, and it isn't changing the graph itself. I think it does change the nodes at some point, but I have to think about, because I don't remember really well how And this is the biggest difference because it might be working on React version because it was done based on the... Because this part I got from the other library, the RiaGraph or RiaVis. So it's not updating the state, and that's the thing. It's just updating the nodes and the edges from the Graphology class, but it never updates the class itself. So maybe it isn't a problem because all I have to do is just change the way that I'm updating the nodes and the edges for the Graphology class and not change anything about the class, so I don't need to create a store or signal for the class itself. I could just create functions that updates the nodes and edges for the Graphology class. It is still... I think that this might not be the case because then like the class is not going to be a part of the thing, which means that it's only going to run once, and then the nodes and edges from the class are not going to have reactivity unless I create a store or signal specific for the values of the class. This is kind of annoying to think about. This here I'm using the nodes from the Graphology class and not the nodes from the store. And the reason why I'm doing like this is because I'm using algorithms that come from the Graphology, so I can't use the objects. Which is something I was thinking about changing as well, but I think it's not worth it to change it for now. Honestly, maybe it's not worth it to change anytime because the layouts are not very important. If there are important layouts that I want, I'm gonna have to think about the algorithms myself because it's gonna be to show specific things. But based on the defaults I have there, it's just for... It's just to give an extra option, but I don't think it's very important. And the other thing that I'm unsure about is this thing here. Because this was using Raph to get. And then I've seen as well, I don't remember really well, but I think it was on some of those streams or some of those videos that he explains that in some situations, because here when you use a store you have to set the value, you can't make it equal. So you can't make layout equals the new value. This doesn't work. But he was saying some, and I forgot, but there are some situations where you can do that. But I don't remember really well. And the problem is that this is going to return an object that has functions. So I'm not really sure if it's going to work if I do like this, because of the way that the store works. So I'm not sure if it's going to update or if I should like assign this to another variable and then here I do some spreading or something. I'm not sure how the diffing is going to work, because this is going to return this function here, this object that has functions. And this is the main part that I'm using the Graphology here, just changing the objects here and then setting there, I think. I think it's not setting anymore. But it's using them to get from here. So maybe it doesn't matter because all the changes that I'm gonna do on the nodes and edges are not related to the... Like I can have the same objects since the beginning here, I think it doesn't matter. As for the layout, the only thing that matters is the positions that it's gonna add to the objects through the functions here. And the stuff related to 3GS doesn't matter for this, so maybe it doesn't matter. You could just leave the class the way that it is, it's gonna work. Hopefully. Because I don't wanna think about this. I think I'm not gonna do this example. I think it's pretty intuitive. Now know how to render lists in Solid with 4, but Solid also provides the index component, which will cause less re-renders in certain situations. When the array updates, the 4 component uses referential equality to compare elements in the last state of the array, but this isn't always desired. JavaScript primitives like strings and numbers are always compared by value. When using for with primitive values or arrays of arrays, we could cause a lot of unnecessary rendering. If you use for to map a list of strings to input fields that could edit every change to the value would cause the input to be recreated. The index component is provided for these cases as a rule of thumb when working with primitives use index. And this is a good thing to know. But not really sure if I understand very well. Isn't the thing gonna be a function there? So I is not a function. I thought based on the previous ones that it was a function, because it is a signal, but maybe not. It's just a value. Didn't it say on the previous ones that it's a signal and not a value? So the recommendation is when you have primitives, you use, so when you have just the simple values, you use the index. Let me read this again. I think I understand what it's saying, but I'm not 100% sure about the details. So, cats is a signal that has an array of objects. So you're looping over this signal. So each thing inside of the thing is a signal itself. Each object inside of the array is a signal itself. No, you now know how to render lists in Solid before, but Solid also provides the index component, which will cause less re-renders in certain situations. Oh, the index component, not this. So it's a different component. When the array updates, the for component uses referential college to compare elements to the last state of the array. But this isn't always desired. JavaScript primitives like strings and numbers are always compared by value. When using for with primitive values or an array of arrays, it could cause a lot of unnecessary rendering. If you use for to map a list of strings to inputs, fields that could edit every change to the value would cause the input to be recreated. I'm not sure if I understand this very well, to be honest. The index component is provided for these cases as a rule of thumb when working with primitives use index. It has a similar signature to for, except this time the item is the signal and the index is fixed. Oh, so it is different. So I think when you're using for, this is a signal. The I is a signal. The item is the signal and the index is fixed. Each rendered node corresponds to a spot in the array. Whenever the data in that spot changes, the signal will update. For cares about each piece of data in your array, and the position of the data can change. Okay, so for, the main difference is the way that they organize these things. So in for is the other way around, I think. Index cares about each index in your array and the content at each index can change. Hmm. So I think that when you're using for is the other way around, maybe? Yeah. So that's the biggest difference. And so that's what I thought was confusing, because I remember on the previous one it was saying that this one is a signal, so it is correct. So when you're using the for, the index is a signal and the other one is the value. And the reason why the index exists is because depending on which kind of data you have here, which data you're mapping over is gonna change the way that you want the data to update. Because the updates trigger the recreation of the components. So I think what this is saying is that when you have simple data structures, you're incentivized to, when you're mapping over simple data structures, you like strings or something else, you're incentivized to use the index, because then the data is reactive and the index is not. And it's probably because there's going to be more change. So it's directly connected with the amount of change you have, I think, the frequency of change. So when you have simple things like the input and is creating strings by mapping, then it makes more sense to have the data as reactive and not the index, because the index changes more often. But whenever you have more complicated data, then it makes more sense the other way around, because then the data has to be reactive, or the index has to be the reactive, and the data is fixed, because the data is more complex. But I'm still not 100% sure if I understand. I think I kind of get it, but not very in depth. Also, the for compares the reference of the array, and the primitives compare by value. This is the actual value, not the reference to the value. That's the difference. Array of arrays. We could cause a lot of unnecessary rendering. We use for to map a list of strings. Edit each. Every change to that value would cause the input to be recreated. Cause the input to be recreated. And because it's compared by value, so it recreates. And if it was comparing by reference, we wouldn't, because the reference is the same. I think that's what's saying. So because the for compares by reference, it recreates every time, and you don't want that. Because the reference for the primitives are always going to be the same. No, I'm not really sure. It would have to be the opposite. The reference for primitives is different. That's why it updates every time when you use the for. So for uses referential equality. Compare by value. But this is what's confusing me, because If the primitives compare by value, wouldn't that mean that they're always going to be the same when you use the for? Because you're using referential equality to compare. Use for to map a list of strings to input fields that could edit each. Every change to the value would cause the input to be recreated. I think what it's saying is that because the string is compared by value, then every time you change, it would recreate the thing. But that doesn't make a lot of sense because in the beginning it's saying that the for compares by reference, so this is the stuff that is confusing me. I think I get it, but it's kind of like the way that it's written is kind of confusing. When you use the for, it's going to update every time because the value is changing every time, and then it's JavaScript is comparing based on the value of the string, and then it's re-rendering the thing, but it's not supposed to be re-rendering. I think that's what it's saying. So it's better to use the index because of that, but it's kind of confusing. I'm not really sure if I get it. So when working with primitives, use the index. Has a similar signature to for, except this time the item is the signal and the index is fixed. Each rendered node corresponds to a spot in the array. Spot in the array. Whenever the data in that spot changes, the signal will update. So or cares about each piece of data in your array, the position of the data can change. So when the data in the array is always the same, you want to use for, because then the only thing that matters is when they change the index. But when you care about the data changing and not the index, then you use the index. I think that's what it's saying. Because with the index is gonna render again when the data changes and not the index. And with the for it's gonna render again when the index changes, not the data. I think that's the main difference. It's kind of confusing to be honest. So I'm gonna move on. We'll study this later. Sometimes you need to deal with conditionals with more than two mutual exclusive outcomes. So this is simple as well, so just talk about it. It's basically like the show, but for whenever you have multiple different conditions. The dynamic tag is useful when you render from the data. It lets you pass either a string for a native element or a component function, and it will render that with the rest of the provided props. This is often more compact than writing a number of show or switch components. And replace the switch statements with dynamic. I'm not sure if I understand. So it just we're passing multiple different components here, I think. And then it just shows depending on the value. That's the thing I don't understand here is that this is... I guess it's just because the highlighting is confusing, but it is like just the 3 components here. So there is something similar I've seen on Twitter some time ago that it was like a tip. That instead of putting multiple ternaries, what you can do is just create an object that holds the multiple different components, and then you can just render the object itself. I think this is the pattern here, but it's kind of confusing. But I think I get it. Like, instead of putting multiple different components, you just create an object that holds key value pairs that represent the components, and then based on the value of a variable, it's going to select one of the keys of the object, and then it's just going to render the component equivalent for the key. And that's what's going on here, I think. But so the options is the thing, the options is the object, the selected is the reactive variable, and then the component that is going to render is based on whatever the selected is going to be. So I think I get it, but it just simplifies this thing here. Sometimes it's beneficial to insert elements outside of the normal flow of the app. Z-indexes are sometimes insufficient to deal with render context for floating elements like models. This is something I was thinking about as well, because one of the problems I have on the app that I'm creating is that one of the customization components is separated from the other ones, and I'm trying to think about a way to put them together, and the problem is that I'm regulating the position of one of the customization components based on the absolute position, and it's just because the place that they are inserted on the trees, one of the customization components has to be inside of the canvas component because it depends on the state of the canvas, and the other is outside because it's going to regulate what kind of graph is shown. But I want to display them as if they're part of the same thing, because then it looks better. So I was thinking about whether or not I can use this portal. And I think that React also has this portal thing, but I'm not 100% sure on how it works. But maybe that's the purpose. I remember that is related to this kind of stuff. When you have two different components, you have components at different parts of the tree, and you want to display them in different ways. I think that's the purpose of this. Sometimes it's beneficial to insert elements outside of normal flow. Sometimes inefficient to deal with render context for floating elements like models. Solid has a portal component whose child content will be inserted at the location of your choosing. So maybe I think this is probably exactly what I want to do. So I would put a portal, I would wrap the customization component with a portal. So this is the component that I'm talking about here. I think it's this one. I wanted to show this component as being as if it was inside of another component that is on another part of the tree. So maybe here what I have to do is just wrap this stuff here with a portal. It's not very clear how the CSS works. Child content will be inserted at the location of your choosing. By default, its elements will be rendered in the div in the document.body. Huh, interesting. In the example, we see our information pop-up get cut off. We can solve this by pulling it out of the flow by wrapping the portal. What is confusing to me is the CSS of this. How does it work? Because so here it doesn't show. I don't get the fundamental thing that is happening here. Like what is doing under the hood? Sure. Is it just changing the CSS? But that wouldn't make a lot of sense. And that's the thing that I don't get about this. Like, what is exactly doing? Is it changing the way that it's gonna update the components, or because changing the CSS doesn't make a lot of sense to me? Because obviously you can just change directly based on the class. So it has to be something, in my mind, related to the structure on the tree, the way that it's gonna update the component. But that's kind of, I don't know. I guess I'm gonna search for other things later, see if I can clarify this. Maybe I'll look for the React something. Yeah, I think it changes the rendering, so it's just gonna change the place that it's gonna update, but it doesn't have anything to do with the CSS. And then you have to do the CSS separately, so it doesn't quite fix the thing that I'm doing. Because yeah, what I want is not to change. I think the only way to fix that is with CSS. What I want is not change the way that it renders necessarily, it's just the way that it shows. Like I want to make as if it is part of the other thing, even though it's rendered in a different place. Even though it's on a different place on the DOM tree. Whatever. JavaScript error originating in the UI shouldn't break the whole app. Error boundaries are components that catch JavaScript errors anywhere in their child component tree. Log those errors and display a fallback UI instead of the component tree that crashed. A component has crashed. For example, let's wrap it in a error boundary that displays error. Yeah, this is very nice. Yeah, not much see here. I think I should just speedrun the rest of the things because it's not very interesting. Maybe I should just read and then pass, not spend a bunch of time. So I want to get to the stores, and I think after I get to the stores and the reactivity, then I'll stop streaming. And then probably try to... I want to watch all these streams here. And then only after I do that, then I think I'm going to change the components here. But probably what I'm going to do is the stuff that I was saying. Just create multiple different values. The main thing that should clarify is the stuff about the updates, the create mutable thing. So... yeah, I think this is like... Svelte has this thing as well, I think. So it's just similar to create a fact, but then it runs whatever you put inside when the component mounts. Let me go to the other one. On cleanups, probably similar to the return on the use fact. This is something that is not very clear to me, is what is the difference between their... What happens when you put a return inside of the create fact? If it is similar to React or not, because they have this cleanup thing here. It makes me think that it's different when you return stuff on the create fact. Some frameworks pair their cleanup methods as return values of their side effects of our lifecycle methods. Since everything in solid render tree is living inside a possibly inert effect and can be nested, we made cleanup a first-class method. You can call it at any scope, and it will run when the scope is triggered to reevaluate and when it is finally disposed. Use it in your components or in your use effect. Your custom directives, use it pretty much anywhere that is part of the synchronous execution of the reactive system. The signal example never cleaned up after itself. Yeah. Events in solid are attributes prefixed with on. They are treated especially in a few ways. First, they do not follow the normal heuristics for wrapping. In many cases, it is difficult to determine the difference between a signal and an event handler. And so, since events are called and don't require reactivity to update, they are only bound initially. You can always just have your handler run different code based on the current state of your app. Common UI events that bubble and are composed are automatically delegated to the document. To improve delegated performance, solid sparse and array syntax should call the handler with data as the first argument without creating additional resources. The example, let's attach the handler to the mouse move event. It's pretty much the same as React, I think. All unbindings are case sensitive, which means that the events names need to be in lowercase. Also, it's all in lowercase. Oh no, you write like this, but then it monitors this. Yeah, it's pretty much the same as React, I think. So next, style attribute in solid accepts either style strings or objects, however the object form differs from elements. And instead is a wrapper for calling style.property. This means that keys take the dash case form, like background color, and that any units must be explicitly provided. It's also okay. So the only difference is on the style thing, I think. Because on my situation there, I'm using the module, CSS module, and then passing as like from the name of the module and then accessing the variable, and it seems to be working. So class to set the class name property on an element, however, is often in combination conditionally set classes. And this is also interesting. You can, because it's also very common to change the class based on one value. So for example, when they hover on or when they click or do something, you just change the class, change the thing. But not very interesting. I think I'm just gonna go over to the store stuff, because I'm already getting tired and I wanna read the store stuff first or last before I stop streaming. And then I'm just gonna go watch the streams off stream. Once I finish the streams, I think I'm going to change. I'm gonna select one of the things to change. One of the ways. It's probably gonna be just, yeah. I think I'm gonna use create mutable, because mutable seems to be better for values that are gonna change all the time. But yeah, I have to study more. Oh, this is probably worth reading because of the spreading thing. Yeah, it doesn't say anything about the stuff. Just gonna go over quickly so I can get to the starting. Yeah, I think now it starts. So I'm gonna go over until this one and then I'll stop streaming. One of the reasons for fine-grained reactivity in Solid is that it can handle nested updates independently. You can have a list of users, and when we update one name, we only update a single location in the DOM without diffing the list itself. Very few even reactive UI frameworks can do this, but how do we accomplish this? In the example, we have a list of to-dos in a signal. In order to mark a to-do as complete, we would need to replace the to-do with a clone. That is how most frameworks work. But it's wasteful, as we rerun the list diffing and we recreate the DOM elements as illustrated in the console log. Instead, in a fine-grained library like Solid, we initialize the data with nested signals like this. Yeah, so it's pretty much spreading and then getting the previous values and then copy the ones that change, I think. So I think that the main difference is that on React, it recreates a entirely new array, but here it just changes the value based on the proxy, because this is a proxy on the signal. So it's getting the same value, but then is changing them based on whatever you pass here through the proxy functionality. I think, not 100% sure. Now we can update the completion state by calling setCompleted without any additional diffing. This is because we've moved the complexity to the data rather than the view, and we know exactly how the data changes. If we change the remaining references of to-do completed to to-do completed, the example should now only run the console log on creation and not when you toggle or to-do. Not sure if I understand very well. I should have done it the other way. Should have looked into the stuff first and then go back if I wanted to. Is that now I'm already kind of tired. Well, let me see. Menu mapping, and it was the only choice available to us in the past, but now thanks to proxies we can do most of this work in the background without menu intervention. So I think it is pretty much like I said there in the beginning. The biggest difference is that on React it recreates everything, and here it just updates through the proxy. So React is recreating the DOM because you're creating a completely new array, so it creates a new reference which forces you to, so it updates the virtual DOM and then it's gonna swap. But here you always have the same data, but then you're changing the actual data with the proxy. So in Solid you change the data and not the DOM, and on React you change the DOM because you're always recreating the objects. I think that's the main difference. Yeah. So, whatever. Stores are Solid's answer to nested reactivity. They are proxy objects whose properties can be tracked and can contain other objects which automatically become wrapped in proxies themselves, and so on. To keep things light, Solid creates underlying signals only for properties that are accessed under tracking scopes. And so all signals in stores are created lazily as requested. The create store call takes the initial value and returns a read-write tuple similar to signals. The first element is the store proxy, which is read-only, and the second is the setter function. The setter function is, in its most basic form, takes an object whose properties will be merged with the current state. It also supports path syntax so that we can do nested updates. This way we can still maintain control of our reactivity but do pinpoint updates. Solid's path syntax has many forms and includes some powerful syntax to do iteration and ranges. Refer to the API documentation for a full reference. Let's look at how much easier it is to achieve nested reactivity with a store. We can replace the initialization of our component with this. So this is what I was going to say, that I wasn't really sure, but now I think it is clear. That when you want to update the whole thing, then you do the spreading operator, because it's doing a shallow copy. So you have to specify everything that is gonna be on the new version, and that's what the spread operator does here. So it's like cloning the previous array, and then it's passing the new value that is gonna change, and then it changes through the proxy probably. But maybe, yeah, I think it is through the proxy that it changes. So it's just it probably, and this is the part that I'm not 100% sure, but I think that's how it works. It does the diffing, which is the comparison of the elements that exist here and this new one. And then if there is a change, it replaces the one that existed on here with this one. And then if you want to have more granular updates, so for example, you want to change only one value here of this object, then you have to specify which one you want to change. And then the other ones you just do the spread operator again, I think, but I'm not 100% sure. Yeah, or you pass it like this, or we specify which one it is that you want to change. So if it's an array, you pass the index, the first element, then you pass the value that you wanna, the key you wanna replace, and then the third is the value. But the question is, like, what if you have more complex data structures? That's the thing that is kind of confusing to me. So let's say here you have a nested object that has arrays inside, and then objects inside of the arrays, and like so on. Would this accept any amount of arguments? That wouldn't make a lot of sense. So, like, my guess is that this always accepts 3 arguments, but then you would limit the levels that you can change. So this is the stuff that is kind of confusing. We'll make use of the stores path syntax with function setters that allows us to take the previous state and return the new state on nested values. Make sure you change the to-dos reference for to-do in the for components. The rest of the assembly will already react granularly. Check the console. The problem here, I think, is that they don't have the, like, I think the only way to learn this is just by using the thing. The reason why I'm concerned with changing is because I'm gonna have to change everything on the app, because there's a lot of components that depend on the store. So, like, depending on the way that I change here is gonna be just annoying as hell to change everything, and just to test like different things to see what is the best way to do it. Because obviously for each one I'm gonna have to change the way that I'm updating, because I'm gonna have to change this function here. And I think that one way this is much better than React, because then it allows you to have this nuance of updating specific things inside of the object if you want, which probably will be very useful in my case. Because when I change the colors of the edges or stuff like that, for example, on the customization, instead of having to update the whole thing each time, I can just select which one I want to update. It's going to become much better, I think. But then it's like kind of annoying, because I want to make sure that I choose that there's a high probability that I choose the best approach in the beginning, so I just don't have to keep refactoring multiple different times. Maybe just a paralysis by analysis thing. But I really want to understand more. I think that the problem is that the documentation or videos, like there isn't any videos or documentation that explains this thing. So the only way to learn is to just do it, and then or maybe look into the source code. Maybe that's what I have to do. Just see. I tried to look into previous posts on the Discord, but this is like one of the biggest problems with Discord, and the reason why I'm not using that much anymore is that it's very hard to achieve a good signal to noise ratio. Because there's a bunch of people, then obviously it becomes really hard to parse the information. Solid strongly recommends the use of shallow immutable patterns for updating states. By separating reads and writes, we maintain better control over the reactivity of our system without the risk of losing track of changes to our proxy when passed through layers of components. This is much more amplified with stores compared to signals. Sometimes, however, mutation is just easier to reason about. That's why Solid provides an immer, inspire, produce, store modifier that allows you to mutate a writable proxy version of your store object inside your setStore calls. This is a nice tool to have to allow small zones of mutation without relinquishing control. Let's use produce on our to-dos example by replacing our event handler code with this. While produce with stores probably handles the vast majority of cases, Solid also has a mutable store object that is available from create mutable. While not the recommended approach for internal APIs, it is sometimes useful for interop or compatibility with third-party systems. So Ymer, I remember seeing from the Zustan documentation, and I think it's just a library that helps you with this stuff of comparing state when you have complex data structures. Because of the way that it works, it just does a shallow copy, and then you have to do the spread operator everywhere, and then Ymer I think helps you with this. So maybe I just have to study this one as well to understand more how the other one works. So what's the biggest difference here? Yeah, so the difference is that before it was spreading here and then passing the object, and here you just pushing the new one to this one. So the framework or the function probably does the work for you of copying the other one and then diffing based on whatever you pushed. It's just kind of confusing. And then here it selects the ID you want, and then it just changes based on this condition, I think. Or it changes the value to the assignment here. Solid provides a context API. Like, I'm thinking about whether or not it's worth it to just go over the source code and try to understand. Maybe I should do that. Because I don't want to spend a lot of time, but there isn't enough information, I think, to clarify all these nuances yet. So maybe it's better to just go over my concern is that the same way, like, I went over the React source code and then like spent a bunch of time trying to understand. So it might be the same thing here. I'm not really sure if there's enough ROI for me to do that. Or if it's just better to just use it and try to see with trial and error how it works. Solid provides a context API to pass data around without relying on passing through props. For sharing signal stores using context has the benefit of created as part of the React system. Right. To get started, we create a context object. The object contains a provider. So I think here there isn't anything new. It's like pretty much the same on React. The only difference is that the overall system that the frameworks use, but the pattern, like from the user interface, the pattern is the same, I think. Stores are most often created in Solid using Solid stores proxies. Sometimes we wish to interface with immutable libraries like Redux, Apollo, or ActionState and need to perform granular updates against these. In the example, we have a basic wrapper around Redux. You can see the implementation in use Redux, the definition of the store, and the actions are in the remaining files. The core behavior is that we created a store object and subscribe to Redux store to update state on update. So the store is the Redux store, I think. Yeah. So this is the store. It's passing the Redux store and then creating the solid store from the Zustan, from the Redux store. The core behavior is that we create a store object and subscribe to the Redux store to update. If you click around the demo, adding items and checking them off, it seems to work pretty well. However, what isn't obvious is that the rendering is inefficient. Notice the console log not only on create, but whenever you check the box. The reason is that Solid doesn't diff by default. It assumes the new item is new and replaces it. If your data changes granularly, you don't need to diff, but what if you do? Solid provides a diffing method reconcile that enhances the setStar call and let us diff the data from these immutable sources, only not notifying the granular updates. So I think I kind of get it, but not really, because like what it's saying is just that the reconcile allows you to only diff the actual things that changed and not the whole object, I think, which would be the store. But what I don't get it is, like, isn't that part of the framework already? Because isn't that how stores work by default? This is the thing that is kind of confusing to me. If we click around the demo, adding item checking off. However, what isn't obvious is that rendering is inefficient. The reason is that Solid doesn't diff by default. It assumes the new item is new and replaces it. Oh, so they're talking about the like, it's because this, in this case, it would be like you are doing the, like, the diffing from the framework itself is it is different from the diffing of the diffing, let's say. So like this is for the diffing of the diffing, I think. So let's say, for example, like, how can I explain this? Like, the framework itself already does the granular diffing, but it doesn't do the granular diffing on the object that is being diffed, let's say. So if you go back on the previous examples where they were adding the to-do thing. So I think that what it's saying is that the Solid framework does the granular diffing when it comes to this object here and this one, but it doesn't do the diffing inside of this one to see if this one changed. And that's what's happening there on the other one. Is that because you're doing the store based on another store, the Redux store, regardless of whether or not the Redux store changed, is always gonna do the thing, because it's just comparing this value with this one. It's not comparing this value with itself, like inside of here. And I think the reconcile allows you to do the granular diffing, where it's comparing the values inside of here to see if any of them changed to do the thing. It's kind of like a meta diffing. As far as I understand now, maybe it's wrong, but... The reason is that Solid doesn't diff by default, it assumes the new item new, so... Granular. Solid provides a diffing method reconcile that enhances the setStore call and let us diff the data from these immutable sources. Okay, I think that's what I just explained is probably correct. Only notifying the granular updates. Now the example works as you'd expect, only running the create code on create. This isn't the only way to solve this, and you've seen some frameworks have a key property on their template loop flows. So that's the thing. I think that's what I was saying in the beginning. Maybe it does make sense to use the Zustan store, because what they're saying is pretty much what I was talking about here. Is that if you use this reconcile, it's gonna allow you to do the granular diffing inside of the properties of the object from the store, and not diff the whole store again. So I think that this solves the stuff that I was talking about in the beginning. So maybe it is better to create the... But the thing that is still confusing to me is that if I do it like this, where I'm just creating the store and the solid substance code is using this reconcile on the source code here, I think. Yeah. It's just reconciling. So if I do it like that, so they are pretty much doing what the documentation there is saying. That they are using this so that the diffing mechanism actually checks to see what things inside of this object here changed. So it doesn't update the whole object. It just updates the thing that actually changed. But the question is, if I do like this, then how do I get the values there on the context? Maybe it is just as simple as this structuring there. So what I was saying before, I specify the name of each thing, like blah 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 blah, and then I just call here, and then I pass the values here instead of spreading like this, because this, like Ryan says, is not very good. Just spread like this, and I think the reason why it's probably not good is because it's kind of unpredictable. I think because this value is reactive, it can have different values at different points. So maybe when it's spreading, is like has some unpredictable reactivity or something like that. And now I'm thinking that it might be better to just use this solid Zustan, and or the other approach would be to doing the way that I'm thinking about doing, because I think that like the biggest issue with doing the solid Zustan, I think, is that it becomes kind of more confusing as well for updating on outside. I think that's the main thing. So maybe what I can do is just do what I was talking about, but then on the object here that is more complex, the data structure, I use the reconcile myself for these ones, and then I just separate in the same way that I was separating. That I said I was going to separate, just create different signals and different stars for different values, and then the more complex the data structure is, you just use the reconcile yourself. So it can get pretty confusing though, because there's a bunch of functions everywhere and a bunch of functions in destructuring. So the problem is that by making that a default part of the templating, you always need to run list reconciliation, and always have to diff all the children for potential changes, even in compiled frameworks. A data-centric approach not only makes this applicable outside of templating, but makes it opt-in. When you consider that internal state management doesn't need this, it means we default to having the best performance. Of course, there's no problem using reconcile when you need it. Sometimes a simple reducer makes for a great way to organize data updates. Reconcile shines here, making our own user reducer primitive. The behavior of reconciler is configurable, a custom key can be set, and there is a merge option which ignores structural cloning and only leaves the leaves. Context is a great tool for stores. It handles ingestion, ties ownership to the reactive graph, automatically manages disposal, and has no render overhead, giving solid fine-grained rendering. If I remember correctly, Ryan also says that it works with a linked list, so it's very fast. Even if you have a very big app, it just like you're gonna loop over a linked list for maximum like 15 times or something like that, even if the app is very big. So sometimes context is overkill though, and alternative is to choose the reactive system directly. For example, we can build a global reactive data store by creating a signal in a global scope and exporting it for other modules to use. Solid's reactivity is a universal concept. It doesn't matter. I think this is the stuff that I was saying in the beginning, that if you want, you can just set the signals and stores as global variables if you don't need to limit the scope. The only time you need to use the context is this situation here, when you have multiple different components that you want to encapsulate the state for the component itself, but you still need the context because you want the data to travel around the tree and not be passed only from top to bottom. So I think that's the only time when you need the context. If you want something global, then you can just set as variables. Solid's reactivity is synchronous, which means by the next line after any change, the DOM will have updated. And for the most part, this is perfectly fine. And Solid's granular rendering is just a propagation of the update in the reactive system. Unrelated changes rendering twice don't actually mean wasted work. What if the changes are related? Solid's batch helper allows to queue up multiple changes and then apply them all at the same time for identifying their observers. In this example, we are assigning both names on a button click. And these triggers are rendered update twice. You can see the logs in the console when you click the button. So let's draft the set calls in a batch. Reactivity on track. It's sometimes desirable to have signal reads or reads not to be tracked, even inside a reactive context. Solid provides the untrack helper as a way to prevent the wrapping computation from tracking any reads. Let's suppose we did not want to log in our example on B changes. We can untrack the B signal by changing our effect to the following. Interesting. Since signals are functions, they can be passed directly, but untrack can wrap functions with more complex behavior. Even though untrack disables tracking of reads, it has no effect on writes, which still happen and notify their observers. So this is when you want a signal to only show in different parts and then disable that. I think it's pretty easy to understand this one. For convenience, Solid has an own helper that enables setting explicit dependencies for our computations. This is mostly used as a terse way to be even more explicit about which signals are tracked, and not track any other signals, even if they are read. In addition, OWN provides a defer option that allows the computation not to execute immediately and only run on first change. Let's have our effect run only when A updates and defer execution until the value changes. I think this one is pretty self-explanatory as well. So the biggest thing that I'm still confused about is the mutable store and the reconciler, but I think that I have a better grasp now. But like I think it's still kind of the same issue that I had before, which is more like from the perspective. It's not so much about how to do something; it's about why. I think there's always going to be several different ways, and then the why is going to depend on the complexity of the situation, which depends on the context, which has infinite potential. So the resolution of the why is going to be a reflection of the computation of the network that perceives the informational field, I think. So like that's what discussion is for. The discussion is computation on the collective consciousness. And is that just the updating mechanism of the accuracy of the information in relationship to the reference frame of the network that creates the informational field. So I think that here is the same thing, where for each specific case, it's going to depend on the way that you distribute the stores and signals, because the state of the application is directly connected with the variance of data from which the code is going to shape. And that's the website. So the challenging part is like when to use each thing. But I think that here, probably the most likely the best way is the one that I talked. Like for some reason, I don't really like that much the idea of using the solid Zustand. Like it doesn't feel to me that it is the best, because even though it's using the reconciler here, or reconcile, like it's still, it's the same thing, gut feeling that I had when I set up the Zustand store in the first place. Is that you're putting everything on like one object, and like in my mind, it doesn't make. It's harder to reason about, I think, or because you're coupling everything together, and that's the thing. I think it makes a lot more sense to have some degree of flexibility. Like even though you want the things to be part of the same thing, because conceptually they serve the same purpose, which I think that the thing that I have there is a very good example. Like they all serve the same purpose of the specific configuration of the graph. But at the same time, I want the flexibility for each thing to be attached to its own updating mechanism. So I think probably the most likely thing that I'm gonna do, the best thing to do, is just to use simple signals for the ones that are strings and booleans. Then for this one, which is an asset object, I create the store and then I use the reconciler myself, or reconcile method myself. And then I pass the actual values to the context. That's probably what I'm gonna do. But before I do all this, I'm gonna watch all these streams here at 3x speed. So that's what I'm gonna do now, and I'm gonna stop streaming. So I'm just gonna watch the streams. After I'm done, I will work on this thing, and maybe I'll stream myself trying to change this stuff here, because it might be interesting. So probably gonna come back either. Probably gonna come back soon, unless I change my mind and then I decide to do this off stream to update. But yeah, I'm gonna continue to do this next time. So see you.